In this section, we are going to explain static routing. Routing is a very important function provided by the network layer. We will explain two concepts here: shortest path routing and flooding. Shortest path routing is also known as Dijkstra's algorithm. The aim of this algorithm is to compute shortest paths using weight on communication lines. But we should pay attention here. The path with the least line may not be the shortest path, and the shortest path may be the fastest one. It can also be the cheapest one. It depends on the means of the weight associated with each line in the topology. For example, we can say in this network topology, the blue path only contains 3 lines, whereas the green one contains 4. However, if you consider the weight on each line, we will find the blue path has more weight than the green one. If the weight of the line is about the delay, we can say that the green one is the shortest path. If the weight is about cost, green one is the cheapest path. We now try to explain the steps of Dijkstra's algorithm. The first step is initialization. Suppose node I is the source node. We can have a collection n equals to I. For all nodes which is not included in the collision, dv equals to L IV. If V and I connected, in which L is the weight on the line. Otherwise, if V and I are not connected, we set dv as infinity. Infinity can be replaced by any number bigger than more than the path, such as 10 powers 9. The step 2 is to look for a node W which is not included in collection N, whose dW is the least, and put W in N. Then, for all nodes which are not included in N, using minimum dV, dW plus L VW to replace dV. We should repeat step 2 until all nodes are included in collection N. This algorithm terminates. We have an example here to explain shortest path algorithm. In this network, we have 8 nodes, and we start from node A. The destination is node D. We are looking for the shortest path between A and D. Initially, we set A as the working node. Following the same algorithm, the 2 connected nodes B and G are marked. Then we pick up B as the working node, as the distance from A to B is the least. B is put into the collection N, and we update the nodes connected with B, which are node C and node E. By repeating this operation, we can find the shortest path from A to D is A to B to E, F, H, and D, with the minimum distance of 10. The next concept is flooding. Flooding works as follows. Every incoming packet is sent out on every outgoing line except the one it arrived on. By doing it, a packet can be guaranteed to be delivered to the destination. We have this example to demonstrate how flooding works. Now, node 5 wants to deliver a packet to node 4. According to the principle of flooding, packet is flooded from 5 to 1, 2 first. When node 2 receives the packet. Node 2 floods it to 3 and 6. Node 3 and node 6 will do flooding as well. Eventually, the packet will be forwarded to node 4. When we go through the steps of flooding, we can find a problem here. There can be many duplicated packets transmitted on the network, and node 4 can even receive several duplicated packets. The solution to this problem can be solved by the following method. Solution 1 is to add a counter in the packet header. Reduce the counter by 1 when it passes a node. Packet is discarded when the counter hits 0. Solution 2 is for each node to set up a register table. Packet is discarded when it arrives a node again. Solution 3 is to flood selectively. It requires the node to obtain the information about the network and determine which node should be flooded. For flooding, the disadvantages are there will be too many duplicated packets and will waste too much bandwidth, whereas flooding also has advantages. It has higher reliability. It can always find the shortest path. Therefore, flooding is frequently used in military affairs. In the end of this section, as usual, we have a question as the quiz to check whether you have mastered the shortest path we explained. We have a network topology. Try to select a shortest path from A to J using Dijkstra algorithm. Please write each working node in order. Answer the shortest path from A to J and the costs. Please label each node after completion. That's it for this section. Thank you.